Hello friends, welcome to Engineering Funda family. In this video, I'll be discussing about microwave frequency bands as well as I'll be discussing about applications associated with different microwave frequency bands. First of all, one should know microwave frequencies are ranging from 1 GHz to 300 GHz. And with this frequency range, there are many frequency bands which is there with microwave. See, here I'll be discussing about frequency bands along with frequency range and applications. If you talk about first microwave frequency band, then that is L band. And L band is having frequency range from 1 GHz to 2 GHz. With this frequency range, there are many applications. One of the popular application is GSM, Global System for Mobile Communication. So our mobiles are communicating with the use of GSM, that is having two frequency bands. One is 900 MHz and second is 1800 MHz. With the use of mobile, we also communicate with CDMA technology, where frequency bands are associated with 800 MHz and 1.9 GHz. With this frequency range of 1 to 2 GHz, which is associated with L band, we also have applications based on satellite phone. So that is how L band is there with microwave. Second microwave frequency band is S band, that is having frequency range from 2 to 4 GHz. See, 2 to 4 GHz is also having one popular ISM band. ISM means Industrial Scientific Medical Band. 2.4 GHz is ISM band, where there are many popular applications available on this globe. Like we can have 2.4 GHz with Bluetooth, with Wi-Fi as well as with Zigbee. So in Internet of Things, this ISM band is widely used, as well as with this S band, we also have applications based on radar, where specifically we use this frequency range for weather and surface ship. Next frequency band is C band, where we have frequency range from 4 to 8 GHz. And this frequency range is specifically used for satellite communication and radar. After C band, fourth band is X band, that is having frequency range from 8 to 12 GHz. With this frequency range, but obviously we have many applications based on satellite communication and radar. But along with that, there are few other applications as well. Like in my college, we are having microwave test bench that is operating at 10 GHz. So likewise, there are many other educational applications as well. If you talk about X band, then one more popular application is there, that is based on remote sensing. See, with SAR, synthetic aperture radar, we can have remote sensing, where by using synthetic aperture radar, we can produce high quality images of this planet. So with the use of SAR, we can understand how exactly geometry is there with this earth by producing high quality images. So likewise, there are many applications which is there with X band. Next frequency band is KU band, that is having frequency range from 12 to 18 GHz. See, this frequency range is having many applications based on satellite and radar, but along with that, there are few other applications as well, like VSAT. In VSAT, we have voice and data communication, and as this frequency range is very high, we have high data rate communication over here. This frequency range is also useful for direct to home satellite TV. So with satellite TV also, this frequency range is utilized. So KU band, that is associated with frequency range from 12 to 18 GHz. Right. After KU band, next band is K band. K band is having frequency range from 18 to 27 GHz. And with this frequency range, we have many applications based on radar and satellite communication. But along with that, one more popular application is there, that is based on infrared astronomy. In infrared astronomy, we analyze planets as well as stars. In infrared astronomy, what we do is we try to identify how particles are associated with different planets, as well as we try to understand what are the internal aspects which is happening with different planets as well as stars. So in infrared astronomy, we use this frequency band, which is K band, that is having frequency range from 18 to 27 gigahertz. Next frequency band is Ka band, that is having frequency range from 27 to 40 gigahertz. And with this frequency range, but obviously there are many applications based on satellite communication and radar. But here you need to understand one more thing. See, here we will be using radar that is having low range and high resolution. So with this frequency, which is there with this Ka band, where we will be having radar with low range and high resolution applications. And in this applications, we are not deal with to identify objects with far distance. We will be identifying objects with low range only, but we will be having higher resolution. Here many other applications are also there. Those are based on military aeroplane. So that is how Ka band is there, where with Ka band frequency range is bit broad. That's why we can have bit higher resolution, but those resolutions are associated with low range with radar, right? See, after Ka band, we have V band, and this V band is having frequency range from 40 to 75 gigahertz. And see, with this high frequency, but obviously wavelength will be there in terms of millimeter, right? And with this frequency range, we have high capacity terrestrial wave communication. And as frequency range is very high, here data rate of communication will be extremely high. One can say one can communicate with the data rate of terabytes, right? So TBPS speed is possible with this frequency range. Now, if you talk about next frequency range, then that is there with W band. See, W band is having range of frequency from 75 gigahertz to 110 gigahertz. And with this frequency range, but obviously bandwidth is quite high. And because of bandwidth is quite high, here satellite and radar applications are there. But here radar will be operating with millimeter wave. So millimeter wave radars will be there. And with those radars, we will be having very high resolution. Resolution means quality of understanding related object. The reason is radar is identifying target, and with millimeter wave, one can identify target with more resolution, right? So here precision of understanding will be quite high with this frequency range. This frequency range is also useful with research. And last frequency band is millimeter band. Here frequency range is there from 110 to 300 gigahertz. It is also referred as millimeter band. The reason is here wavelength is there in terms of millimeter. And with this frequency range, we have millimeter wave radar applications as well as satellite communication applications. So that is how various frequency bands are there with microwave, and with each of these bands, different applications are associated. When you talk about microwave frequency bands, then by default you can say those frequency bands will be having applications based on satellite communication. The reason is line of sight communication is possible with frequencies in terms of gigahertz, right, which is there with space wave propagation. But along with space wave propagation, also distinguished applications are there. That's why I have made this video. Here one thing that you need to note down, see how frequency ranges are there with this different band, that one should know. The reason is when we talk about language of communication engineer, at that time we communicate in terms of L band, C band, X band. At that time one should know what is the frequency range which is associated with those bands, right? So that's why this video is quite essential for you. I hope you have understood this. Still, if anything that I would like to share, just note it down in comment section. I'll be happy to help you. Thank you so much for watching this video.